But if you're skipping school, coming for you. No. So yeah, we're going to talk about mineral characteristics and classifications. They start with an introduction to minerals. Basically, you should know that almost everything we build, literally almost everything, comes from the ground. Plastics and rubbers come from oil and gas production. Obviously, oil and gas and all of our hydrocarbons come from that. Every metal that we have has to be mined out of the ground. Every brick, every material, there's nowhere else on this planet to get things other than in the ground. Unless you're talking about wood or things that we grow, in which case, trees and plants need minerals to survive and to grow. It all goes back to what's in the ground and minerals, where they're at, what their distribution is, how we get to them and make use of them. A couple things real quick about minerals and which ones we use. Salt, like every bit of salt that's ever been on McDonald's French fries comes out of the ground. We mine salt to eat that, and your body needs salt to survive. What else? Glitter was a very early mineral, like biotite and muscovite. They used to make makeups and powders and glitters. Talcum powder is talc, like the baby powder that we have. You use gypsum to spread across your yard to help keep your grass clean. There's all sorts of minerals that we use every single day that have to be mined. And so mineral mining and production is a very important thing. Yes?
So you know how we have to have salt to survive, right?
That's more of an old school thing, but yes.
What if we never discovered salt mining in the crowd?
Well, before
before
we got into industrial mining, salt was very expensive for that reason. And there's an old saying about a person being worth their weight in salt. We know worth its weight in gold because gold is expensive. Back in the day, salt was more expensive than gold because gold is nice, but it won't keep you alive. You gotta have salt for your body to work properly. Now, in non-filtered waters, in water that you're just drinking from the lake or the river, there's salts in that. Not a huge amount, but there's some. And so your body's naturally going to get some salts. But you got to make sure you got a salt-heavy diet back in the day. Now, today, everything has salt. You will never, as an American in modern times, be salt deficient. Most of us have too much salt in our body, and we need to reduce our sodium intake. So don't go out and like extra salt your fries tomorrow. Just know that you get plenty of salt. That's an old school thing before we had technology and nice stuff. So let's see. What is a mineral? Specifically, the one thing I want you, we're going to go through this, but the one overarching thing I want you to remember, minerals, and I don't know that they have it written here. They should. It should be the first thing that's written anywhere. Minerals are the building blocks of rocks. Every rock has to be made of minerals. If it doesn't have minerals in it, it's not a rock. And that's just how it is. So in order to talk about rocks, you've got to talk about minerals and what minerals are inside there. And specifically, we have criteria for what is a mineral and what's not a mineral. First off, minerals have to be naturally occurring. Is there a difference between a diamond and a cubic zirconium? Let's just start with price.
Yes.
Yes, diamonds are expensive. Cubic zirconiums are sold cheaply at Walmart. Why? Because, somebody here? Who's here? Oh, just strolling in all late. No tardy pass or nothing. Just like, here I am. Oh, see, now I feel bad. We talked about this earlier. Like, making fun of the person that, like, took a day off. You're like, oh, did you enjoy your day off? And they're like, yeah, someone died. Or you're like, oh, you're late to class. The first period, someone was like, I was at the orthodontist. I'm like, oh, my bad. So, yeah, you always want to be careful razzing people for coming in late or missing a day. You never know why they missed. You could turn into the bad guy. Watch, he wasn't even at the doctor. He was at Whataburger or something. No, I'm just missing.
Whataburger do sound good.
Yeah. But don't eat too much salt. You missed the salt conversation. So listen. Minerals have to be naturally occurring. If we make it as a human being, it's not a mineral. So technically, we can make diamonds in a lab. We can't call them diamonds. A diamond is a diamond. A cubic zirconia is exactly the same, but it wasn't made in the ground. It was made in a lab. Therefore, it's less expensive, and you can't use the name diamond for it. So literally, you can't go into a store and buy a cubic zirconium that they're calling a diamond. That would be illegal. They have to call it a cubic zirconium.
So if you put it on a diamond tester, it's fake.
It depends on what it is. From what I remember from school, there are subtle differences that you should be able to spot. So like a trained gemologist will be able to just look with a magnifying glass and tell you whether it was made in a lab or it's natural.
No, I'm just saying, like, would it
But-
give you whatever, like, pass?
Well, it depends on what it's looking for. Is kind of what I'm saying. If the computer knows what to look for, no. But if it's just testing like chemical composition and hardness, yeah, same chemical composition, same hardness. It's going to look the same. But there are subtle differences that, yeah, if the computer knew what to look for, it would be able to figure it out. So that's number one. It has to be naturally occurring. Although humans use minerals to make many technological objects, minerals themselves are formed by natural processes. That's the key part. It has to be natural. Number two, close that Chromebook. Minerals are inorganic or non-living. There are a couple things that kind of push the boundary between this. One of the good examples is pearls. Pearls are made from what? What makes pearls? Where do you find pearls?
Shells.
In a clam. It's like the same material as the clam shell. So you pop open the clam shell, and right inside is a little pearl. Pearls are made from organic materials. They're made from living things. And so pearls, while pearls themselves are not living, it kind of like pushes this borderline between what's a mineral and what's not a mineral. Yes.
Is it like real ones?
Yeah.
What, pearls? Oh, yeah. Yeah, you find a natural pearl, if it's the right shape and color, yeah, they can be expensive. There's people that go diving for a living looking for pearls. Yeah, you can. If you live in the right part of the world, you can do that. Now, a good example of this would be what Terry said is shells. When the animal's alive and the shell is part of the living animal, it's not considered a mineral. Once that animal dies and its shell sinks down to the bottom of the ocean and gets covered up with other rocks and becomes part of the rocks, then it transitions to a mineral. And so this living, non-living thing, there are situations that make that kind of muddy. But just know that it has to be natural and it can't be something alive. Like my bones are not minerals. They're made up of elements, but it will never be considered a mineral geologically wise.
Wait, even if you like bury something in the dirt stuff.
Yeah, your bone's not a mineral. Now, if it's a fossilized bone, like a dinosaur bone, a lot of those have been replaced with minerals. But the bone itself is gone and dissolved away or like rotted. But what you have left, that's why like petrified wood, and if you've probably held petrified wood at some point in time, or if you haven't, like you probably haven't held a dinosaur bone, they feel like rocks. It's like it feels heavy like a rock instead of light like a bone, because minerals were replaced it. But the original bone is not a mineral.
Some of the original bones still be there, though.
Some of it is, yes, but technically, is it a mineral? No. But yes, sometimes original bone is still there, for sure. Number three, minerals are solids with characteristic crystalline structure. There are no liquid minerals. So water is not a mineral. Now, is ice a mineral? That gets a little iffy. There's people that are arguing either way. Technically, yes. Ice, so look,
What if it melts?
is ice a solid? Well, it could melt, but if it's ice, it's not melted. If it's ice, it's not melted.
But if it melts, it can't be.
Well, but anything can melt. If I get it hot enough, anything can melt. So ice, technically, at like the North Pole, the ice is solid. Does it have a characteristic crystalline structure? That's where water gets a little iffy. Water's crystalline structure may not be as rigid as they want here. The atoms that make up the minerals occur in repeating three-dimensional patterns. That does happen. And these orderly arrangement that gives crystals their characteristic shapes or crystal forms. And we'll see this when we get into crystal shapes. Why do some minerals have like six-sided shapes? Why are some of them flat? That's all because what the atoms are doing inside. Number 4, a mineral has a fixed chemical composition. Different minerals may have similar crystalline structures. For example, both halite and galena form cubic crystals. They form these like really cool, perfect cubes, just like a square, like somebody cut it, but nobody cut it. It formed in the ground that way. But they have different chemical formulas. Like water, what's the chemical formula for water? It's H2O. It doesn't matter where on the earth you go or what kind of water you drink. There might be other things in there. It might be muddy water. It could have pee in it if it's a swimming pool. It's still H2O. It's all H2O no matter where you go in the world. So that definite chemical composition is important. So those are the 4 things. It's got to be natural. It can't be made in a lab. It's got to be inorganic. It can't be living or part of a currently living thing. It has to be solid and have a crystal structure, and it has to have a definite chemical composition. I can't just throw any willy-nilly chemicals in there. It's got to be a specific chemical formula. So those are the 4 things they asked for. Let's see. Do we want to watch a What Are Minerals video? No. Characteristics of minerals. What do we look at for minerals? And this is important because these are the things that we look at to know whether they're useful or not. Hardness is going to be number 1. If it's hard or not, that tells us what we can use it for. Diamonds are used on rings and jewelry pretty often. Why? Because if I smack my diamond on something, is it just going to shatter? No. If it were glass, it would just shatter. Diamonds are valuable because they have nice color, they're very clear, and they're extremely hard. So if I spend $5,000 on a diamond, I have a reasonable expectation that 10 years from now or 100 years from now, that diamond's going to look pretty much the same as when I bought it. There's not a lot of things that are going to be roughing up my diamond. That's important if I'm spending that much money. Crystal form is important. Diamonds we can cut into these nice, cute little patterns that reflect light really well. That helps us with what we want to do. Let's see, what else? They got color, hardness, crystal form. Other physical properties are luster. This is how shiny or not shiny it happens to be. Fracture or cleavage. They have cleavage and fracture. This is how it breaks. So if it breaks in a flat plane and it has flat lines, it's got cleavage. If it just breaks like a rock or a broken piece of glass, that's fracture. Streak is like color, but it's powdered color. Some things look different in powder form than they do in their solid form. So we break it up and powder it up and see what the color looks like there. And then there's a couple other things. What kind of thing could I use to find out if something is salt or not? What does salt do that's differently than other things?
It dissolves.
And does it have like what do we use salt for?
It tastes good.
Yes. So if I like tasted a piece of salt, would I know that it's salt?
Yes.
Yeah. And I could probably guess that there's not too many things that taste like salt, or we'd probably use those too. And so salt, this is going to sound crazy, but you literally lick it. And if it tastes like salt, it's salt. And if it doesn't, it's something else. And hopefully you didn't lick anything back. Huh?
Kills germs too.
Yes, salt is naturally antimicrobial. It's not like hand sanitizer or nothing, but I would wipe it off if you just saw someone else lick it and don't lick it right after that.
I just wouldn't look at it.
But you know, I will tell you, John Mabry. I don't remember John Mabry. He licked a piece of Jurassic salt that I had. So like literally dinosaur age salt. He's like, oh, tastes like salt. So you got to do what you got to do sometimes. So another property would be like phosphorescence. They glow. Have you seen? Of course you have. You've seen the stuff that glows in black lights. Has like the nice like green orange stuff. There's rocks that naturally do that. There's even rocks that will naturally glow in the dark. You put the black light on them, you let it soak it in for a little bit, turn all the lights off, and they're still glowing afterwards. That naturally occurs in nature. Yes.
Where's that place where, like, when you move the water, it lights up where?
Oh, that's the phosphorescent stuff. There's a couple places it happens more often, but it can kind of happen anywhere. Yeah, it's bacteria in the water, and when you disturb it, it releases light, kind of like a firefly, but they're all in the water. And so you kick through the water, and it looks like the water's glowing. Yeah, that's the same kind of phosphorescent kind of stuff. What else? There's chemical reactions that can happen and different stuff like that, but that's pretty much it. What do I got down here? So classifying minerals. There's a couple different ways that we do this. One of the ways is by what kind of stuff is in it. So silicates are going to have silicon and oxygen. Those are going to be your two main elements from the periodic table, silicon and oxygen. Non-silicates are going to be more like metals. They're going to have heavier metals. They're going to have different types of elements that come from the middle of the periodic table where our different metals are. So let's see. Do they give us some explanations here?
Why is titanium so expensive?
It's just because it's rare and hard to get. We'll talk about it in a second. So look, silicates are one group here. Silicates are the most common thing. So this makes up the vast majority of the elements in the rocks. Non-silicates are very important, and there's lots of different groups of them, but they're just a lot less common than what the silicates are. Silicon and oxygen are two of the most abundant elements in the earth, and so these rocks show up a lot. For non-silicates, you got carbonates. They have carbon and oxygen. You have halides. Halide is salt. So these are your different salts. You got rock salt. You got fluorite, which we put in our toothpaste and our drinking water. Oxides are going to be metals that have oxygen attached that can rust. You got sulfates, sulfides, and native elements. Native elements are minerals that are also just one element, like gold. Gold is an element, right? It's also a metal that fits all the definitions of a mineral, so gold is also a mineral. What'd you say, titanium or platinum or what? Was it titanium? Titanium is also a natural element. You can get titanium just by itself. It's a mineral. Where's titanium? Oh, TI, yeah. Titanium's expensive because it's hard to mine from the ground, and it's relatively rare, and so it's all like supply and demand.
But it's strong, isn't it?
It's strong in some ways, but not in others. So it depends on what you want your metal to do. Huh?
I saw a video. Somebody shot it like a stick, like quarter inch.
Oh, yeah. But if you're trying to build like a bridge, it's not going to have the flex that you want. And so, yeah, it's got good properties, but it's not the end all be all. Sweet. I'll have a nice day. Yes. You're done. Thank you.
They shot it with like,